Okay, so today we're looking at differential equations and forming differential equations, and we're basically trying to find the general solution. So solving these equations means to make y in terms of x, so without a dy by dx. Okay, so this is kind of the last stage of things. And you might think to yourself that, well, dy by dx, that's differentiating. So what has this got to do with integration? Well, we'll talk about why that is in a second. So the first thing that you do with these types of equations is you need to split them up, and you basically have everything with x on one side, everything with y on the other side, including the dy by dx, and then you can deal with them from there. So let's have a look at this one first. Now this one here is not too bad, it's quite an easy one. So I'll do this one and then I'll give you a chance to have a go at some yourself. Okay, so the first thing I need to do with this one, so dy by dx is equal to xy plus y. Now the problem I've got straight away is the fact that I've got that x and the y together. So how am I going to get that y on its own? Take it out as a common factor, yes, good. So it's going to be dy by dx is equal to y bracket x plus 1. And then I need to divide by the y and bring the dx up, okay? So I end up with, and it's always worth writing it, instead of like dy over y, write dy, because we know that dy means in terms of y when we're integrating. So instead of writing it dy over y, we'd write it as 1 over y with respect to y is equal to x plus 1 with respect to x. Then what we need to do is, if we want to get rid of all of our, if we want to get rid of the dy by dx, then what we do is we integrate both sides. So we're going to integrate this and we're going to integrate this. So then what I need to do, what is the integral of 1 over y with respect to y? ln y, yeah, good. So it's going to be ln y is equal to x squared plus x, what else? Plus c. Now, you might think to yourself, well, why have you got the c on one? Yeah, x squared over 2. You might think to yourself, sorry, I was thinking about this next stage. You might think to yourself, well, why have you only got c on one side? Why do you not have c on both sides? And you do have c on both sides. However, what we do is we basically take into consideration that we're just moving it to the other side. If we're combining those constants together. Does that make sense? Everybody all right with that? And the next little stage of this is you would we want to make y the subject. Okay, that's what we're trying to do. We're trying to make y the subject. So the last little stage of this is that we well, what does ln mean? What's the base of ln? Yeah, base is e. So this is going to be y is equal to e to the x squared over 2 plus x plus c. Now, there's one little stage that we don't use anymore, and it's the we don't keep the c as a power. We know that if we're adding powers, it's the same as doing what? Yeah, multiplying. So you don't need this step. I'm going to do this step now, but later on, we're just going to put, well, you'll see what I mean in a second. So this is the same as saying y is equal to e to the x squared over 2 plus x times by e to the c. But e is a constant, isn't it? We know that e is a constant, so we know that e to the c is also a constant. So the way that we write this is y is equal to some constant a times by e to the x squared over 2 plus x. Have they given us any values to work it out? No. So that's your final answer. Everybody all right with that? Yeah, can us have a thumbs up, thumbs middle, thumbs down? Good. Quite straightforward. Yeah, they do get a little bit trickier, these, especially when you've got to generate your own Generate your own example. All right, so we'll look at this one next here. So the first thing I need to do here is to split everything up and have everything with x on one side and have everything with y on the other side. Now, because I've got dy by dx on my left-hand side, I'm going to want the y's on the left-hand side to keep that as, because if we had it on the other side, it's going to be 1 over dy by dx, isn't it? And we want dy by dx because we want it in terms of, sorry, we want dy on the left because we want it in terms of y. So, I'm going to take the x on the right to the left. I'm going to leave that my fault. I'm going to take the 1 plus x squared from the left to the right. I'm going to take the tan y down, and I'm going to have, it's going to be 1 over tan y with respect to y is equal to x over 1 plus x squared with respect to x. What are people thinking with that 1 over tan y? What are you thinking kind of moving ahead? It's going to be cot, yeah. So it's probably worth writing this as cot y. Why would I write that as cot y and not 1 over tan y? It's easier to integrate, yeah, that's it, yeah, good. So I'm going to want the integral of cot y with respect to y is equal to the integral of x over 1 plus x squared with respect to x. What do we notice about that one? What do we notice about the right-hand side? Hard. Thinking about all the integration that we've done. You might think partial fractions. The answer is no to that. Okay, why are we not using partial fractions for that? Go on. Yeah, that's exactly it, yeah? That bottom differentiates to the top with an extra constant, doesn't it? Can everybody see that? Yeah? That 1 plus x squared would differentiate to 2x, and you've got the x on top. That's the hard part of integration. Do you understand that this isn't partial fractions? Okay? Because the bottom differentiates to the top. Okay? So if I know that the bottom differentiates to the top with an extra 2, what's my integration going to be of that, right? A half of ln 1 plus x squared. Yeah? A half of ln 1 plus x squared. Or you can do ln of 1 plus x squared divided by that. That's exactly what it's going to be. So we also need to know what the integral of cot is. We're going to need to use our formula booklet for this one. Okay. What is the integral of cot? Well, if I look at the integral of cot is ln sine y in your formula booklet. So ln of sine, well, ln of sine x it should be, which is ln of sine y, is equal to a half ln of 1 plus x squared plus the c. Everybody all right with that? Everybody all right with that so far? Yeah? So the next stage is there's 2 things we need to get rid of. We need to get rid of that half, and using the laws of logs we know what with that one. If it's a half in front of the ln, we're going to bring that up and it's going to be the square root. Yeah, good. Now the other part is that c, that weird c. Now previously we made it e to the power of something, but with this one here we use a different technique again. So here we'd write it as ln of sine y is equal to ln of the square root of 1 plus x squared, mod of all that, plus ln, okay, That is still just a constant. But the reason I've written, well, what is the reason I wrote it like that? Because now I can combine all these, can't I? Okay. Now I can say that this is equal to ln of sine y is equal to ln of k times by root 1 plus x squared, all modded. Everybody right with that? So then I can cancel those ln's on both sides. Cancel that one, cancel that one. And I end up with sine of y is equal to k root 1 plus x squared. And then the final little stage is to get rid of that sine, so it's going to be sine to the minus 1 or arc sine. So y is equal to sine to the minus 1 of k root 1 plus x squared. Everybody all right with that? Can you see the difference and the reason why I used the constant as ln k this time instead of this one here? Because in this one here, you've got one thing in terms of ln, but the other one isn't. You basically take everything up and put an a in front and put your constant in front, because you've got two different, well, you've got one in terms of ln and you've got one just in terms of x squared plus x. Here, on this one here, because they're both in terms of ln, so you've got ln sine y and ln of square root of 1 plus x squared, because both sides are in terms of ln, you then use the constant as ln to bring it together and to get everything together. Does that make sense? Yeah? Super. Everybody right with that? Cool. So let's have a look at this one then. So now we're just gonna step it up one extra layer now, okay? And now we're actually going to be thinking about generating an actual equation. So previously we just had a constant in there, which was c or in k. But usually what they do is they give you a value to work out what that c and k is. Okay. In fact, do you want to get started on this one yourself? Do you want to have a little go at this one yourself to get you started? I think you should be able to do that. I'd suggest, do you want me to do the first line for you? Just so you know. Well, what I'm going to have on the left-hand side? Yeah, going to keep the y on this side, so it's going to be the integral of 1 over y minus 2 is equal to minus 3 over 2x plus 1 and x plus 2, the integral of that with respect to x. Everybody right with that? How am I going to do that? What technique of integration I'm going to use for the left-hand side? It's just what? ln, yeah, but what do I need to do on the right-hand side? Partial fractions, yeah? Okay, off you go. You have a go at that. I'll start doing it in a little second. You can see now that we're basically using everything. Okay, we're using substitution to do it in, we're using partial fractions, we're splitting up to create a differential equation. There'll be context to this as well. It'll be something like gravits or something along those lines. Do you want me to get started on this? Everybody all right? Have I made a mistake? Have I made a mistake? I did have my answers for A and B. What were the answers to A and B? Lost them, they've gone. B is 1 and A was -2, is it? So you end up with the integral of 1 over y minus 2 with respect to y is equal to the integral of -2 over 2x plus 1 plus 1 over x plus 2. Is that right? Yeah? With respect to x? Is that all right? Yeah, everybody right with that? And did everybody get that? Yeah? Then what we need to do is we need to integrate it. So it's going to be ln of mod y minus 2 is equal to minus 2 ln mod 2x plus 1. Everybody right with that? Yeah? Plus ln Yes, sorry, you do need to divide by 2. Sorry, yeah, good, yeah. Divide by the differential, yes, sorry. Mod of x plus 2 plus, and I'm literally just going to write, because they're all in terms of ln, instead of writing plus c, I'm going to write plus ln k. Is everybody right with that, yeah? Okay, so they will cancel, won't they? The minus and the minus there. So that will cancel. It leaves you now. Actually, well, let's write it all in terms of ln first. So ln mod of y minus 2 is equal to, if we're subtracting that one there, it means we're dividing. We're also timesing by that k because it's addition. So it's going to be ln mod of k times by 2x plus 1 all over. I've done that wrong way around, haven't I? X plus 2 all over 2x plus 1, like so. Everybody all right with that? Yeah? So then we can write that y, because we're just going to, well, we're not cancelling the ln's. It's just because they're both in terms of ln, then we know that whatever's in there must be the same. So it's going to be y minus 2 is equal to k times by x plus 2 all over 2x plus 1. Now, what we don't know yet is what that k is. But how do I work out what that k is? You substitute in our two values, which is when when x is equal to 1, y is equal to 4. So if I sub those two values in, so when x is equal to 1, y is equal to 4, I end up with 4 minus 2 is equal to k times by 1 plus 2 all over 2 times by 1 plus 1. 4 minus 2 is 2 is equal to 3k over 3, is it? So k is equal to 2. Now we're pretty much finished. We just need to write down what our differential equation is. We do need to take that 2 over as well. So the last little stage is it's going to be y is equal to 2 times by x plus 2 all over 2x plus 1, and then take that 2 over, so plus the 2 there. Everybody all right with that? Thumbs up, thumbs middle, thumbs down. Good, good, good. Good, good, good. Everybody all right with that? Oh. Where is there a mistake there? We've got all of that. It's all right, isn't it? And apart from that, and then that last stage, it comes from nowhere. Does this factorize somewhere? So let's just expand it. So maybe it factorizes, I don't know. So it's going to be 2. No, it doesn't. We're right. We're right. Anyway, we're definitely right. Have a go at that one yourself, please. Have a go at that one yourself. Can you see it here? Yeah, have a go at that one yourself. What am I thinking when I see that 3 over cos squared? Cos squared x. It's going to be what? It's going to be sec squared x, and I can actually integrate sec squared x, can't I? There's a direct, well, no differential. Something is to go to x sec squared. This is the way you use your formula. Yeah? Yeah. first step. You're just getting everything with a y on one side, everything with an x on the other. So here, this one, take the y up, so it's going to be y dy by dx. Take the x up to the other side, so it's going to be 3 over cos squared x dx. Yeah, 3 over cos squared x dx, taking that dx up. Yeah? Does that make sense? Yeah. Yeah. Well, you're timesing both sides by y, aren't you? If you times both sides by y, then this is just going to be y dy by dx. If you times this side by y, the y is going to cancel. Yeah? But yes, you're right. You're basically taking the denominator, and times it by. X squared is a differential. It's tan differentiate x squared. No. You're looking at integration, yes. Tan differentiates set squared. The set squared will integrate. Yeah, that makes sense. Yeah, not set. Yeah. Set squared integrates set. If you get set, then you use the integral. That one's a reverse differential. Sorry, differentiation. You know, tan differentiates set squared integrates tan. Whereas if you just got set, then there's like a few like where you're looking at the differential formulas rather than differentiation. No, that makes sense. Hey, come on. Yeah. No. Good question. Good question. Hannah's just asked, does the y on this side integrate to y squared dy by dx? It doesn't, because the reason you're leaving this dy on this side is you're basically saying integrate this, whatever it is, with respect to y. That's what that dy means. And then on the other side, you're saying integrate this with respect to x. Does that make sense? That's what that dx means, yeah? So it's going to be y squared over 2. But it wouldn't be dy by dx anyway, because that's differentiated. Alright, so we'll start with this then. Alright, so I'm going to take the y up. I'm going to take the y up. So it's going to be, bring that y up. So it's going to be y, do it over here, y dy is equal to 3 over cos squared x with respect to x. And then I'm going to integrate both sides. So I end up with the integral of y is, as you said, y squared over 2. Ugh, I should have wrote this one. Sorry, I'm going to do that first. Write the right-hand side as something we can integrate, which is going to be equal to the integral of 3 sec squared x with respect to x. So then integrate it. Y squared over 2 is equal to 3 sec squared integrate to 3 tan squared, isn't it? Yeah. So 3. I was thinking about the. Sorry, yeah. I was thinking about what's inside it though, because there's just an x. There's nothing else there. So it's 3 tan of x plus the c. Yeah, we are going to leave it in c because there's no ln's involved. But we now need to do the last little stage, which is just to work out what my c is, and I do that by subbing in my two values. In this case, x is equal to pi over 3, pi over 4, when y is equal to 2. So I end up with 2 squared over 2 is equal to 3 tan of pi over 4 plus c. What is 3 tan pi over 4? What is it? 3. So this is going to be 2 is equal to 3 plus c. Everybody right with that? So then c is equal to -1. In which case my differential equation is y squared over 2 is equal to 3 tan of x minus 1. So let's times up by the 2. Y squared is equal to 6 tan of x minus 2. So y is equal to the square root of 6 tan of x minus 2. Everybody all right with that, yeah? Brilliant. Super. Everybody all right with that? They've left it in terms of now. It doesn't always need to be in terms of y, okay? It doesn't need to always be in terms of y. If I'm honest, I probably would have. I did think that I was going to leave it. If it was me, I would have left it at this stage here before I square rooted. I probably would have left it at this stage, just because this can be easier to manipulate if we need to manipulate it any further. You get the marks for that as well, and it shows you that in the mark scheme. Okay, so some key points for differential equations. Now we've already spoke about these. Get your y's onto the left-hand side by dividing, possibly factorizing first. After integrating it, you have the ln on. If you have the ln on the right-hand side, make your constant ln k. Be sure to combine all your ln's together, like you did in question 2. Then, if you have your boundaries, sub it in to find out if you know what your boundaries are, then sub them in, or you know a particular point, then sub it in to find out what that constant is. And then exam questions love partial fractions with this one. Yeah, partial fractions usually comes up all the time in this. Okay. All right. Last part of integration, and the last thing that I am ever going to teach you new. Okay. That's sad, isn't it? All right. Forming differential equations. Forming differential equations. So, with these questions, you have to be really careful to read and understand the questions, okay? The rate of increase of a rabbit's population with P, where time is T, is proportional to the current population. Form a differential equation and find its general solution. So, we started having a look at these before, didn't we, in differential equations? We talked about the word rate, the rate of rabbit increase to the population is proportional to its time. So our starting point here is to say that we know that that rate means what? What does the word rate mean? The change. Yeah, so it's going to be the change in P over the change in T is proportional to the current population, which in this case is going to be equal to P. That's your starting point here. Everybody all right with that? Everybody okay with that? So basically, this means here that the rate of change in the population is equal to some constant times by P. Everybody all right with that? So we've already had a look at that, and now what we're doing is we're using that information to form and solve a differential equation. So we do that by, in this case, bringing all the p's to the left-hand side and bringing the dt to the other side. So my first point for this one is that 1 over p with respect to p, the population, is equal to some constant k with respect to time. And I'm going to integrate both of these sides. Everybody all right with that? So I end up with here, on the left-hand side, well, what will I end up with on the left-hand side? ln of p is equal to, what happens if I integrate k with respect to t? It's going to be kt, yeah? That k is a constant, so it's like saying 2. This is going to be equal to kt. Now, because both sides aren't in terms of ln, I'm just going to put plus c. Everybody all right with that? So then my last little part here is to write this in terms of p. And we write this as p is equal to e to the power of kt plus c. However, I don't like that plus c in my power, so I write it as p is equal to a e to the kt. Yeah? We're using that as a constant. And this is why we get exponential growth. Okay? This is where exponential growth comes from. Okay? Because of that simple fact. Because that simple fact that the population growth is proportional to the current population. So the bigger the population is, the quicker it's going to grow. Exponentially. Okay? Does that make sense? Yeah? That's where we get this exponential growth from. Everybody alright with that? Yeah? Cool. Everybody got that down? I do enjoy these when they get into it. Here we go. Here we go. This is a trickier one. Okay? This is a trickier one. Have you got this one in your notes? Yeah? So, water in a manufacturing plant is held in a large cylindrical tank of diameter 20 meters. Water flows out of the bottom of the tank through a tap at a rate proportional to the cube root of the volume. Show that t minutes after the tap is open, dh by dt is equal to minus k third root of h. Okay? Where did that even come from? All right. Now, I've actually got a friend who works in waste management who actually his job is to do this. Okay? His job is to actually do this. So, like, he forms differential equations on waste, on the rate of flow. Remember I think I've talked to you about this before, haven't I? I've got a friend who works. And, like, I saw his wall, and I was looking at all these differential equations, and I was thinking, why have you got those differential equations? Well, yeah, he works in this, he works in waste management. So, these kind of things crop up everywhere. And this is one of the reasons why differentiation and differential equations are so important, because they crop up in the weirdest little places that you wouldn't expect. Okay? So let's have a little look at this one first of all. Let's have a look at this one. So we've got to do the first part here first. So let me just read it again. Water in a manufacturing plant is held in a large cylindrical tank of diameter 20 meters. Water flows out the bottom of the tank at a rate which is proportional to the cube root of the volume. Proportional to the cube root of the volume. So the first thing we're going to need to do is to work out what that volume is, aren't we? What that volume is. Because it's got a fixed diameter, we can work out what that is. So let's write down what the volume is. So the volume of a cylinder, well, it's going to be the circle on the bottom times by the height in this case. We've got a radius of 10. So it's going to be pi times by 10 squared for the circle times by h. So 10 squared is going to be 100 pi h. Yeah, everybody all right with that? So this is equal to, I will write that down actually. So pi r squared times by h. So V is equal to pi times by 10 squared times by h. So my volume here is equal to 100 pi h. That's our first stage. So then we've got to think about what the sentence says. Okay. So I'm going to highlight this. Water flows out the bottom of the tank. Water flows out the bottom of the tank at a rate. So there we're seeing the rate. Okay. So this is the rate of volume flowing out, which is proportional to the cube root of the volume. So it's proportional to the cube root of my volume. And we know what that volume is. We know that the volume is equal to this down here, 100 pi h. Okay, so the next stage of this is we need to form an equation for that. So water flows out the bottom of the tank at a rate. Okay, so we're thinking about the volume and we're thinking about how it leaves the tank. So it's going to be our volume dV by dt is proportional to the cube root of the volume. So it's going to be the cube root of, in this case, 100 pi h. Everybody all right with that? So this is equal to dV by dt is equal to some constant, let's call it k, times by the cube root of 100 pi h. Now we know that we can split that up in terms of like surds, if that makes sense. Okay, that Matthew. Yes. Would it? No, yeah, you're going to have a negative k. Now, they have actually put a negative k in there, but because it's flowing at a rate, I will put that negative k in there, but because it's flowing out, but you'd get that in the, when it pops out anyway, you'd end up it being negative, if that makes sense. So, like, you can put it as negative, but to be honest, they do that in the questions, but it will pop out at the end anyway when you know what your constants are when you're subbing them in. Does that make sense? Okay, I will put that in there because it's flowing out, yeah, but that just means that you're going to end up with a double negative. It means the k is positive, but when you were to do it before, you'd end up with a negative value because you know it's flowing out. Does that make sense, Matthew? Yeah, it's a good point. It is a good point. So what we're looking at here, and the reason I've got to pause is because they're not asking for the rate of change of volume. I thought I'd finish that question. They're asking for the rate of change in the height, aren't they? Can everybody see that? They're asking for the rate of change in the height. So actually, I need to then change this. So if I want the rate of change in the height, that's going to be dh by dt is equal to, because that's what I want, I want the rate of change in the height, is going to be equal to dh by dv times by dv by dt. That does work. However, I think it's easier to do it the other way around. I think it's better to start off with dv by dh and then think about that and then to use the formula. So let me just change this here. Now I only know to do this because, again, I've done lots of these questions before. So I'm going to write this as dv by dh is equal to dv by dt times by dt by dh. Everybody all right with that? And then we'll use that at the end to flip this round, if that makes sense. You'll see what I mean in a second. Because I know what dv by dt is. My dv by dt is this part here, the minus k root of 100 pi h. We know that, okay? The one I don't know is dv by dh. So let's work out what dv by dh is. And how would I work out what dv by dh is? What is dv by dh? Differentiate v in terms of h. What is dv by dh? Yeah, dv by dh is equal to 100 pi from the highlighted part. Yeah? So dv by dh is equal to 100 pi. And now I've pretty much got everything, haven't I? Okay? Because I know what dv by dh is. It's 100 pi. I know what dv by dt is. It's this part here, this minus k cube root of 100 pi h. Okay? And this is what I'm trying to find. So let's just sub in now everything that I've got. So I'll highlight the things I've got and where I've got them from. So dv by dh here is this, isn't it? This is the blue bar. dv by dh is that part there. Everybody all right with that? Yeah. dv by dt is this part here. dv by dt is this part here. So I know what that is. And I'm trying to find out what dh by dt is. That's what I'm trying to find out. Okay? Everybody all right with that? So let's sub in all these values that I know. So dv by dt is... dv by dh is equal to 100 pi is equal to, dv by dt is equal to minus k third root of 100 pi h. Everybody all right with that? Times by dt by dh. Everybody all right with that so far? Yeah? Because it's times by dt by dh, I can bring the dh up, I can bring the dt down, and I can bring the left-hand side down to be over 100 pi. So this one here is dh by dt is equal to minus k cube root of 100 pi h all over 100 pi. Everybody all right with where that's come from? Everybody all right with that? Yeah? So, in which case, I've made a little mistake here. It's not a big mistake. The mistake is the fact that I've used k as my constant. I probably should use something else as my constant here because we're trying to find out what k is, if that makes sense. But it doesn't make too much difference. So if I look at this here, these two equations now are the same, aren't they? Okay, these two equations are the same. The difference is that this here, the k, is this part here. So can you see how I've used k, and actually I should have used something like c, maybe. So k, that highlighted part, is equal to minus some constant c, cube root of 100 pi over 100 pi. So the cube root of 100 pi over 100 pi. Does that make sense? So that blue part, which I've just highlighted, now notice I've changed the c to k because the starting point was k. Can you see why I've done that? Do you know what I'm talking about? Because it's constant, I should have used a different constant at the start. But usually when you're doing proportion, you use k, don't you? Annoyingly. Is everybody alright with that? Yeah? Ish. Yeah? So all I'm saying here is this is the equation that I wanted, and I've got the equation that I want here. It's saying what is the value of k? The value of k is all of the part here, which is all my constants, which is some constant times by the cube root of 100 pi, all over 100 pi. So this k here in front of this is this part here. I've just changed the constant to c. Does that make sense? So the thumbs up, thumbs down for that. Okay, it is messy. But it's the last question, isn't it? It's the last question of the work. But it's going to be tricky. All right, part A. So that's part A. Okay. So part B says, show that the general solution of this differential equation may be written h is equal to p minus qt all over, to the power of 3 over 2, where p and q are constants. Okay, let's have a look at that then. So the next part. I need a lot of space. So at the moment, this is what we've got. We've got dh by dt is equal to, I'm going to change that k to c. So minus c cube root of 100 pi h all over 100 pi. Everybody all right with that? Yeah? So, annoyingly, let's write this. I'm going to split this up, so I'm going to write it as dh over dt is equal to, I'm going to write this constant as a constant. Okay, so minus c cube root of 100 pi all over 100 pi h to the power of a third. Can everybody see what I've done there? Yeah? Everybody alright with that and where that's come from? Yeah? So, then I'm going to take the h onto one side. I'm going to bring the t up to the other side. So, it's going to be 1 over h to the third with respect to h is equal to minus c cube root of 100 pi all over 100 pi with respect to t. And I'm going to integrate both of these sides. Everybody all right with that? Yeah? Okay. Let's write h as a negative a third, which is where, when we integrate this, what am I going to get? What's negative third integrated? Positive 2 over 3 divided by 2 over 3, so times by 3 over 2. So if I integrate this side here, it's going to be h to the power of 2 over 3 times by 3 over 2. Is everybody all right with where that's come from? I'll add the step in. This is the step. So for this side here, I'm going to write this as h to the minus third in which case when I integrate h to the minus a third, I need to add 1 to the power, which is going to be h to the 2 over 3, then divide by 2 over 3. So this one here becomes h to the 2 over 3 divided by 2 over 3, which is the same as saying times by 3 over 2, is equal to, now all of this, it looks horrible, but that is just a constant, okay? So this is equal to minus c third root of 100 pi all over 100 pi times by t plus another constant, okay? And that constant I'm going to check what the constant is actually because I messed it up last time. I'm going to call that constant C. Everybody right with that? Yeah, good point. I'm going to call my constant. I'm not following the same as what they're doing. I'm going to just call it n. Okay, I'm going to call it n. Now, because just following what we've done here, all of this here is just a constant, okay? All of this here is just a constant. So we don't actually need to write it all like that. We can just write it like a constant, okay? So actually, let's write that as a constant. Let's write the m as a constant. And let's write all of this like this. So 3h to the 2 over 3 all over 2 is equal to some constant times by t. Now we know that with that constant, following it through, we should times by the third root of 100 pi all over 100 pi. But because that doesn't actually matter, I'm not trying to find out what my initial constant is. It can be any constant. I'm just going to write this as kt. I probably should have done that earlier, to be honest. And I'm going to call this plus m. I'm going to keep it as m, just for argument's sake. But is everybody all right with that? Yeah? Then I need to times up by 2, divide by 3. However, if I'm timesing constants by 2, it's just going to be another constant. If I'm dividing my constant by 3, it's just going to be another constant. So I end up with h to the 2 over 3 is equal to this same thing. They're going to be different constants. So I'm going to call them different constants. And the constants I'm going to call them now are the constants that they want, which are p and q. So p qt plus p, like so. Is everybody happy with where that's come from? Yeah. What do you mean? No, you don't need to define it. No. So then, it's not going to make any difference anyway, to be honest, because that's going to pop out as a negative, and it's a constant. So it doesn't really matter whether it's positive or not, to be honest, because when I sub my next values in, it's going to come out as a negative value. Does that make sense? It's because it's a constant. You can define it as negative, you can define it as, but because we're almost getting rid of everything we're timesing by, aren't we? Okay? So I'm not going to worry too much about that yet, Matthew, because when I pop the next part in, it will come out as negative, all right? Although I do know and appreciate that they've got that minus q up there. And to be honest, that would never happen in the exam. They wouldn't be expecting you. They'd just have it as a plus, to be honest. That's exactly the way they do it. Because minus q is the same as plus q because it's a constant, which is going to come out when I actually do my next stage. Does that make sense? Yeah? I will put it as minus just because they've got it as a minus, but as I keep saying, it doesn't matter because I've got all that constant coming through. So then I'd need to cube all of this and then square root it. Okay, because remember, if I'm doing the inverse of 3 over 2, it's the same as doing to the power of 3 over 2 on the other side. Sorry, if I'm doing the inverse of 2 over 3, it's the same as the power of 3 over 2 on the other side, isn't it? So this is h is equal to p minus qt to the power of 3 over 2. Yeah. What's that, sorry? That's what I've got rid of. I'll do the step. I'll show you where it comes from. So the power of 3 over 2 means h cube rooted all to the power of 2, doesn't it? Yeah. So which is equal to p minus qt. If I square root the other side, so to get h on its own, I need to square root to get rid of that squared. And then I need to cube to get rid of that. So this is equal to h is equal to the square root of p minus qt all to the power of 3. That makes sense? Which... What? Yeah. Oh, that one? The timesing by? Yeah. So this is kind of what everyone keeps kind of mentioning. It's like, well, that should be a negative. It shouldn't be anything. The reason this is disappeared is because it's a constant. Okay? Which is why I wrote it as a KT. Okay? When I'm timesing by 2, I'm timesing constant by 2, which is still a constant. Okay? So 2 times by this here stays as some constant times by t plus some constant. Does that make sense? Then when I divide by 3, it's that constant divided by 3, t, plus that constant again. Does that make sense? So in a way, you're kind of just wiggling this around to make it look like what? Here, you should have all of this. You should have the times by 2 as well. You should have the divide by 3. But because all of that is just a constant, when you're doing all of that, a constant times 2 is still a constant. Constant divided by 3 is still a constant. Does that make sense? So it's not disappearing. It's just because you're timesing by that and you're dividing by that. And because they're both constants, they're going to be a constant that pops out as a weird number anyway. That makes sense? Yeah. So this is equal to h is equal to p minus qt all to the power of 3 over 2. Yeah. Now this is kind of why I said that you shouldn't really have that negative there. Yes, we know that it's negative, and yes, we will know that it's negative. But if I had that as positive, when I sum it in, this would come out as negative anyway, and that's the point. Does that make sense? Yeah? Everybody all right with that? Ish. It's the horrible part is the fact that we're timesing and dividing by constants by values. So that's why all of this is disappearing here, this highlighted part. Okay? It's disappearing because it's just a horrible constant. All of this then, the 3 over 2 disappears because you're timesing constants by that, you're dividing constants by that. That makes sense? Yeah? So that's part B. Part C, I think, gets a little bit better and nicer because actually we start to sub in our values and we start to kind of work things out then, and then all of those horrible constants become a number. Okay, so let's have a look at this then. So part C, so we know that part C, we know that h is equal to p minus qt to the power of 3 over 2. It says initially the height of the water is 26. Now that tells me when t is equal to 0, h is equal to 27. Everybody all right with that and where it's come from? Because it says initially. Okay? And the second part, it says 10 minutes later, the height is equal to 8 meters. Now, I'm just going to check, is t in minutes? Does it say that? It does say t in minutes, yeah? So t is in minutes, so when t is equal to 10, h is equal to 8. So when t is equal to 10, h is equal to 8. So the whole point is we've got to the stage where they're basically giving you your differential equation. We're trying to find out what P and Q are. So even if you couldn't do that part before, you can still do part C and D. Does that make sense? Yeah? Because they're giving you the differential equation to find out those constants P and Q. And it wouldn't matter whether this was that horrible thing up here, this C to the minus, and it wouldn't matter whether it was negative, and it wouldn't matter whether it was this, which is the cube root of pi over 100, because all of that would disappear, and this would just be two numbers which I'm working out. Does that make sense? Yeah? So let's work out what those numbers are then. And to do this, we're subbing in these two values, and we're creating simultaneous equations. So my first one, I'll probably sub in when t is equal to 0 first. So if I do that, I end up with 27 is equal to p to the power of 3 over 2. Everybody sees where that comes from, yeah? So 27 squared, all cube rooted. Cube root of 23 is 3. 9, is it? P is equal to 9? Yeah. So P is equal to 9. So then I will sub that in. So H is equal to 9 minus QT all to the power of 3 over 2. So then sub in 8 and 10. So 8 is equal to 9 minus Q times by 10 to the power of 3 over 2. Cube root of 8 is 2. All to the power of 2 is 4. So I end up with 4 is equal to 9 minus 10Q. Everybody right with that? Take the 10 over, bring the 4 back. I end up with 10Q is equal to 5. So Q is equal to 0.5. So then I end up with my differential equation, also my equation, which is H is equal to 9 minus 0.5t all to the power of 3 over 5. Now, if I'd have left this as a positive value, which I could have perfectly well done, there's no reason really why I shouldn't be able to do that. The only difference is that this positive q will come out as negative q. Does that make sense? Everybody right with that? Yeah? So that's part C. Gets a little bit better now. And then the last part, part D, find the time in minutes when the depth is equal to 1 meter. So all we're doing in now, the last little part, is we sub in 1 into this. So D, find when H is equal to 1. So then we go 1 is equal to 9 minus 0.5t all to the power of 3 over 2. So this is going to be 1 is equal to 9 minus 0.5t. Take that over, bring it back. 8 is equal to 0.5t. So t is equal to 16, is it? 16 minutes, because that's all. Yeah, everybody right with that? That first part is horrible with all of those times of valid constants and things like that. And they kind of all disappear, don't they? They all just disappear because constant times a constant, divided by a constant. I could put them all in, but constant times by constant is just a, constant times by 2 is just a constant. Another constant, if that makes sense. Everybody all right with that? Super. All right. Let's give us a little bit of headspace. Yeah. Yeah, you can. Alright, we've got one final question to test your understanding. What time does lesson finish? 25 past, okay. So this is your final question. Off you go. Have a go at this yourself. Probably about the same as this, so like maybe about 11 or 12 or something. It's a chunk, isn't it? You'd be able to get the first one right as well. A. With practice.